Hello, geometry folks. This is Mr. Heron. We are back with unit number 7. Unit number 7 will be anything and everything that could possibly happen with circles. We'll talk about the usual stuff, radius, circumference, all those key terms. We'll talk a little bit about what happens when lines cross in circles and kind of the relationship there. We'll also be talking about what happens with angles when lines cross inside and outside of the circle. And just kind of some of the basic terminology that you need to be familiar with. So we'll start with circles and circumference, kind of what that means. A couple of nuts and bolts things first, okay? A circle is basically a set of points equidistant from a given point called the center. That is actually how a circle is defined, okay? So you have all these points that are all equidistant from a given point called the center. So, and it is named by the point in the center, okay? That's how it is named. It is named by the point in the center of the circle. So this would be circle C, okay? That's what this would be. A radius is basically anything that starts at the center and goes out and ends on the circle. Okay, so it is named by 2 points because it is a segment. So in this case, I could have CD, or I could have CE, or CF. Those would all be considered, any one of those would be considered a radius. A chord is a little bit different. Basically, anything that starts and ends on the circle would be considered a chord. So in this case, AB would be the best definition of a chord. And then the diameter is basically a chord that goes through the center. It passes through the center. Endpoints are on the circle. So in this case, my diameter would be DE. Okay, so circle, radius, chord, diameter. Chord is probably one of the few things you haven't seen before. The other ones you've seen before but may have forgotten about. Looking next, so if we look at some of this stuff, so as we look here, the name, so this would just be circle P. Radius, you could say PL or PN, either way would be fine, you only need one. LN would be fine, okay, and in this case, a chord, MN would be a perfectly fine example of a chord, okay? Remember, a chord has just got 2 endpoints on the circle. Doesn't have to be anything special. It's just got to start and stop on the circle. For the one on the right here, this will be circle E. Radius, there's only going to be one in this case. Well, actually, there's a couple. I could say EG, or I could say EH, and I could flip those letters around. They would still be the same. But those are going to be, any one of those would be considered a radius. My diameter, there's only one of those. That's going to be HG or GH. And the chord is going to be JK. Okay? So that's just kind of understanding that what each part is. So my center is the letter in the middle. What's a radius? What's a diameter? Chord? You need to be familiar with that. Okay, so now as I look, QV is going to equal 4. Okay, so let's mark that. QV is going to equal 4. What is the diameter of the circle Q? So I know Q is the circle I'm talking about because that's what the letter in the center is. So now if QV is 4, radius is always going to be half of the diameter. So this is my radius. So a radius never changes distance. So if this is 4, this length is 4, which makes this length also 4. So I'm going to add those two together and simply get 8, okay? A radius is always going to be misspelled. No, just kidding. A radius is always going to be half of the diameter. All right, so that's going to be the relationship there, okay? So if I take my diameter times 2, or divided by 2, and then or take my radius times 2, that would get me my diameter. All right, so now if I jump down here to number 3, Still dealing with the same circle. TU, this length here, is 14 feet. So now what's the radius? Well, this Q ends up being a midpoint between this length and this length. So each one of those would just be 14 divided by 2. So that's going to be 7 and 7. So my radius will be 7. All right, nothing too brain-breaking. Just understanding that a radius is going to be double diameter. Half of a diameter is going to be your radius. Okay, so congruent circles basically are exactly what they sound like. They are the same size. The radius is going to be equal. So that means like GH, that radius would be congruent to JK. All right, that's going to be congruent to JK. So the radii, or the two, each radius is going to be equal to another radius. Okay, so that's what congruent circles means. It means same size circles. Concentric circles have the same center, but as you can see, kind of one is fully inside the other, or one is fully outside the other. Kind of the easiest way to think about this would be like the Target logo. You know, the bullseye. Those are concentric circles. Okay, one that all have the same center, but all have the same center, but don't touch or don't cross over anywhere. Okay, so intersections of circles. Here's kind of my possibilities. All right, so you can have it cross twice. You can have it touch once. Or here you have none. Okay, those are your three possibilities. You can touch once. All right, you can touch twice, or they won't touch at all. So this is kind of what we were talking about before. Concentric circles are going to be the ones that never touch. Okay, so they can touch twice, they can touch once, they can touch none at all. Okay, so let's take a look here. The diameter of circle S is 30. The diameter of circle R is 20. And DS is 9 units. Find CD. Okay, so first off, CD is this itty-bitty little length right there. Okay, so but we've got some overlap. Okay, CD is part of both circles. Okay, CD overlaps in part of both circles. Okay, so let's look at kind of the information they gave us. So circle S, the diameter is 30 units. All right, so diameter is 30. So this, let me change colors here. This whole thing is 30, which means this is 15, and this whole length is 15. Okay, the diameter of circle R is 20 units. Okay, so my diameter is going to be 20, which means this is 10, and this length right here is 10. From R to D is 10. Okay, now they tell me that DS, all right, DS is 9 units. All right, so DS is 9 units. So how big is CD? Okay, so here's kind of what I'm looking at. I apologize, it's a little messy. All right. Here's kind of my big part. This whole thing, I know, is 15. Okay, I know that DS is 9. I know from here to here is 9. That length right there is going to be 6 units. How do I know that? Because the entire, that length from C to S is 15, because I know that the diameter is 30. All right, I also know that D to S is 9 units, so that means this has got to be 6 units, because 9 plus 6 equals 15. And that's my answer. That's my answer. So now if I look here, same kind of idea. Diameter of circle X is 22. So like this whole length is 22. That makes that 11. That makes that 11. All right, this thing right here is also 11. Diameter of circle Y is 16. So that whole thing is 16. That makes that 8. That makes that 8. That makes this whole length 8. WZ is 5 units. They want you to figure out X to Y. Okay, now what I can do is say this. All right, I can't just go 11 plus 8 and say, oh, it's 19. That would be wrong. Okay, because 11 plus 8 counts this length, this WZ, twice. Okay, there's 5 that's included with the 11. There's 5 that's included with the 8. So I can't just add those two. What I need to do is, since it's counted twice, okay, I need to subtract it once. Okay, so since it's added twice, I need to subtract it once. Okay, so it's going to be 19 minus 5. So the real answer is going to be 14. Okay, 14 units. That's going to be my answer. The reason is because this 5 is part of both radii. Okay, it's part of the XZ and it's also part of WY. It's part of both circles. So you have to account for that. Circumference is just the distance around a circle. So if I was going to, go right here, just get dropped off and start walking in a circle, how far did I walk? That's pretty much it. Now, what you need to remember is that the circumference, to figure that out, you're going to take this diameter and you're going to multiply it times pi, okay? The Greek symbol pi, which is 2 lines with a little almost tilde on top. So for this one, it's just going to be the diameter times pi, or because of the relationship with diameter is just twice the radius, I can just write it as 2r pi. All right, so my circumference is just my distance around the circle. That's going to be it. So now RT is 10, figure out the circumference of circle V. So now RT, this length right here, so RT is a diameter. So circumference is diameter times pi. So all I'm going to do is write my exact answer would literally be 10 pi. That's my answer. All right, 10 pi units. That's my exact answer. The reason it's exact is because that is a full representation of the answer. Okay, once I multiply 10 times pi, throw that in a calculator, I get 31.42. This is rounded. I rounded this off. Otherwise, I would still be writing the decimal out. But this is my rounded. This is my exact answer. So exact answer needs to have the pi symbol. This is often referred to in terms of pi. Okay, and that all that means is you don't multiply by pi. Okay, you want the exact or the in terms of pi, because that means that you don't have to do more steps. So here you have a circumference of a circle with a radius of 2.5. All right, now remember, radius needs to be spelled correctly. Radius is 1/2 the diameter. All right, so I need to double the radius to get my diameter. So that's going to be 5. So the diameter of this circle is going to be 5 units. All right, so my exact is going to just be 5 pi. So then I multiply it out, you end up with 15.71. That's my answer. Okay? Again, nothing too brain breaking, a little bit of just kind of keeping things. All right, find the circumference of a circle with a diameter of 16 feet. If you understand what you're doing, this should take you not very long at all. So again, circumference is diameter times pi. The diameter is 16. So this would be the exact answer, 16 pi feet. So when you go one step further and do a little calculator mashing, I get 50.27 feet. And that's going to be my answer. That's kind of it. One of the big points is, do they want an exact answer or a rounded answer? If it's an exact, if they ask for exact and you give a decimal, you're wrong. Okay? Now, I'm not saying, like, you know, if you get a diameter of like 2.5 pi would not be wrong, all right? But if you multiply it by pi, it would be wrong, okay? So when I say decimal is wrong, there is a little caveat to that. Basically, I'm not looking for this, okay? No, don't do that. All right, so crop circles have been discovered in Canada. The largest of the three circles had a radius of 30 feet. Figure out the circumference. So a radius of 30 feet. All right, the circumference then is what? So remember, I need to double the radius times pi. That's my circumference. So that's going to be 60 pi, and that's going to be in feet. Now, that would be in terms of pi or an exact answer. In this situation, we would want a rounded answer, kind of get an idea how big around the circle is. So that would be 188.5 feet. All right, so it's about 188.5 feet around that circle. Okay, so asteroid hit Earth and created a huge crater. They measured the distance around the crater at 78.5 miles. That's a big crater. What is the diameter of the crater? How far is it across? So distance around the crater tells me, hey, this is the circumference. So circumference is going to be diameter times pi. So, but we know that that's going to be 78.5 miles. So now it's a matter of solving. A little division by pi. So my diameter would be 24.98, or approximately 25 miles. So the diameter, this thing was 25 miles across, which is pretty insane. Okay, find the diameter of a circle to the nearest tenth. Nearest tenth means I'm okay with a decimal answer. Nearest tenth means I'm okay with a decimal answer. The circumference, 65.4. So diameter times pi. I know that this is 65.4. So I'm going to take 65.4 divided by pi. So that is going to give me 20.82 is my diameter. So down to the nearest tenth would be just be 20.8. So then divide it by 2 to get the radius, which would just be 10.4. So you've got a diameter of 20.8 feet, radius of 10.4 feet, diameter and radius. That's my answer. Okay, a couple of new terms: inscribed, circumscribed. Inscribed, here's the difference. A circle falls if all the vertices lie in the circle, in a circle, if all of the vertices lie on the circle. Circumscribed, right. So inscribed means the circle is on the inside And circumscribed means that the circle is on the outside. So this would be considered circumscribed. The alternative would be if I had a square and I had a circle fully encompassed inside. So that would be it. Yep, inscribed, the way I think about it, inscribed, circle, inside. So, sorry, inscribed, the circle is inside. Circumscribed, okay, the circle is outside. Okay, just a couple terms to be familiar with. All right, a square with a side length of 9 inches is inscribed in circle J. So in this case, it's a little bit different because the square is inscribed in the circle, okay? So a square is inscribed in the circle. All right, so the square has a side length of 9 inches. Find the exact circumference of circle J. So how do I figure this out? Well, I would do Pythagorean theorem to figure out my diameter. So that's going to be 9 square root of 2. And all I did was remember some 45, 45, 90 rules. All right, so I'm going to go 9 times the square root of 2. So my diameter is going to be 12.73. And you can absolutely do Pythagorean theorem. You know, work that down. You will absolutely get the same answer. So then my circumference is just going to be 12.73 times pi. So my circumference is going to be 39.98, or approximately 40 inches. Okay? All right, we're getting down to the nitty-gritty here, I promise. Find the exact circumference of K. All right, find the exact circumference of K. So that means in terms of pi, no decimals. So now when I look here, when I'm looking at this triangle, 3 square root of 2, I know that these two are equal. I know that that's a 90-degree angle. That automatically makes it a 45, 45, 90 triangle. And the relationship there is like this. Remember, 3 square root of 2, that's like x square root of 2. So to solve for x, divide by square root of 2, divide by square root of 2, x is going to equal 3. So that means each side of this is 3. So my diameter is going to be 6. So my circumference is just going to be 6 pi. There's my answer. So a circumscribed square, hold on 1 second. Exact circumference of a circle with a circumscribed square. So that means the square is on the outside with sides of 10 feet long. All right, so the square is circumscribed. So here we have our square. Then we have a circle inside. Each side is 10 feet. Okay, so that means that my radius is going to be 10 feet. So my circumference is just going to be 10 pi feet. All right, they want the exact. Pretty straightforward. Okay, how did I know which one was which? Well, a circumscribed square tells me that the square is on the outside. All right, finally, circumference. We already talked about this. Just to recap, diameter times pi, or twice the radius times pi. All right, thank you very much. Get going on the 7.1 assignment and the 7.1 quizzes.